here he is. So please welcome Manico.
Right. Thank you very much, Sebastian. Before we start, I have to do one thing real quick. All right, let's do this, everybody. You ready? All right, show me some Swedish cheer here. Let's do this. Woo! Thank you. Gotta get a little selfie. Gotta get a selfie. I'll tweet that out later on. Hello, everybody. My name is Jim. I'm going to be your speaker for today. Hey, is that good? Hey, okay. That's all the Swedish I know. Okay. Let's talk about cross-site scripting. So let's talk about cross-site scripting from a defense point of view. My name is Jim Manico. I'll be your presenter. I'm a former board member of Owasp. I've been doing software for a long time. I am from Hawaii. Aloha. This is my cheat sheet for XSS defense. Now, we're going to explain what this is, but this topic, from a defensive point of view, it's mostly about web-based user interface defense. So who here is building web-based user interfaces in their work today? Lots of us. Who's using Angular? Who's using React? Who's coding HTML by hand in Notepad? Yeah, really? Are you serious? No. VI? Yeah. Emacs? Yeah. Sublime Text? Yeah. Okay, good. So this is like a cheat sheet for all of the defensive knowledge you need to have while building a user interface. If this was a Facebook relationship status, what would it be? It's complicated. All right, it is a little complicated. It is. There's a lot, and the problem is that the standards that we have today to build user interfaces on the web have almost never considered security. Never, even to this day. And so we, as a developer, are forced to do the security ourselves. And unfortunately, it's so complicated that very few web applications are able to get this correct. So we're going to try to fix that and provide the right knowledge. So before we go too much further, what is cross-site scripting? Per, what's cross-site scripting?
Oh, no.
Yes. What's Per's nickname, by the way? Say it. No. Come on, Victor. Victor, say it. Do you work with Per?
I wish.
Come on, say it. What's his nickname? Mutual. All right. I promise him I would never do that again. What is anybody? What is cross-site scripting? Help me define this. Go ahead. What's your name? Hugo. What you got?
Mixing up a bunch of code inside user-defined data, and then when it gets mixed up, that's when you get cross-site scripting.
That's okay. I like that definition. Anybody else want to add to that? What is cross-site scripting?
Injection.
It's a kind of injection into a web application's user interface. The way I define it is when the attacker can submit JavaScript to your website that another user of the website executes. And then so some user is using your website and they execute JavaScript that didn't come from your programmers, but came from an attacker. That's basically what cross-site scripting is. So if I have a URL that has evil JavaScript in it, so I'm the attacker, I see a vulnerability, and I build a URL with evil JavaScript, I can send a copy of that URL to a victim. The victim clicks on that URL. The JavaScript payload executes, and as one of many attacks, I can steal data from that web page, and then the data can be collected by the attacker. So I can use evil JavaScript that I can inject into your website to steal data, as well as many other attacks. The other form of cross-site scripting we'll talk about is stored. For example, I might submit something to your application, like it might be a comment system. Like we're reading a news article about how great Sweden is, and underneath this article are many comments where people say, I agree. Oh, I agree, so do I agree, great. And then some attacker says, I agree with some evil JavaScript. Oops. Then some victim reads that article about how great Sweden is, and they execute that evil JavaScript. So that code, that comment from the attacker lands in the browser of the victim, the code executes, and we can now steal data from the victim in some way. But let's look at attack payloads. These are from some of the world's best. This will help us understand deeper what cross-site scripting is. Here's an attack. Again, suppose I was on the news website. We're reading an article, and I post a comment with this JavaScript. What does this do?
Gives away all my
I'll leave. Per was in class with me today, and he was sitting right up front, and I kind of like gave him a hard time the whole day. And now that he's here, I want to continue. Does anybody here know Per? Who knows Per? Anybody? Per has a new nickname. His nickname is Mutual TLS. Remember? Oh, that's his. All right.
Yeah, no problem.
I have promised him I would stop doing this for a full day now, right?
Yeah.
And I'm,
Yesterday.
how has the promise been?
American?
American. Just kidding. What does this attack do? Remember, I launched the attack in your website, and then the attack lands in the victim's browser. What does it do? What? It's stealing cookies. I first build an evil URL to my attacker website. I then add the cookie. Remember, where does this attack execute? In the, I'm sorry?
On the client.
Whose client? The attacker's client?
No, the victim.
The victim's client. So this lands in the victim's client. I get a copy of the victim's cookie. I then use an image object. It's not displayed, it's just an object, and I call .source, and it tries to load the image. And in doing so, it sends this URL to my server with a copy of the victim's cookie. If I can steal somebody's cookie, what can I do with it? What can I do, Hugo?
Anything in the context of that user.
Yes, I can conduct actions as if I was that user. I can't log in as them. I don't know their password yet, but I can at least execute actions as if I was the user. This is very serious. What does the user see in the browser when this attack launches, Hugo?
Probably nothing.
That's the right answer. They see nothing. It's happening behind the scenes. There's nothing visual that happens here. New image is just an object. It's not rendered on the DOM yet. By the way, if this cookie was HTTP only, we wouldn't be able to read it. But what I can do is, I might not be able to read the cookie, but I can always use it. So in this case, I have an AJAX request. Again, this is attack. I launch this attack into your website in some way. I get this into a JavaScript application. I can then make an AJAX request to connect back to your email system, and I'll send a copy of this email to your boss at work, and the subject is you're a jerk. I'm not saying your boss is a jerk, it's an attack, right? Again, if the user is already logged into this webmail, when we use single sign-on, we're often logged in all day long. Do I need to steal the cookie to make this attack work? No, I don't. That's the thing. Even if this cookie is HTTP only, even if this cookie has the security flag same site, even if this cookie used token binding, right? It would still execute. It would still cause the transaction to submit. The point I'm trying to make is cross-site scripting is very serious. It's so serious that even if I can't steal data, I can force the user to make any transaction that I want. Any post, any get, any put, any patch, whatever verb I want, I can make that request go. And that's what real attackers do. They don't just try to steal data. They try to force you to make transactions that can do harm in some way. So this is very serious, even though it's difficult to defend against. I'm gonna skip that, forgive me. Here's another attack. This is, I was in Poland teaching class. So Legia Warsaw is one of the football teams from Poland. I'm just joking around here. Here's an attack to deface the website, right? I have a script. The bad team, awesome team, I say Legia Warsaw kicks worse than my mom, and any other team is great. And here's the defacement. I say document, body, inner HTML. That overrides the entire body of the web page and defaces the whole website, right? And so, yeah, there we go. Here's another attack. This is a stored phishing attack. I launch this attack, and I can compress the attack if I want to. I want to show you the whole attack here. I first start by overriding the body's HTML. I add a login form that when you click on the login button, it tries to steal the password. We grab a copy of the password. We use the same image trick to send the password to my server. It's a way I can steal a password by putting a forged login form into your website. How do you stop cross-site scripting? Any idea? How do you stop? Any ideas how to stop cross-site scripting? Yes, sir.
CSP?
I think that's a great answer. I'm going to discuss. CSP is like, even if your defense goes wrong, content security policy can save you. Should you still write secure code? Oh yeah. So I'm not going to talk about content security policy that much. I'm going to focus on the other defenses to fix the code, because content security policy, it doesn't fix your code. The attack still launches, but content security policy will stop it from executing. So I like it, but I still want you to write secure code. And the way we do, what a lot of people will say, how do you stop cross-site scripting? They'll say use a filter. Try to filter out the attack. You think that's a good idea? No, it's not. It's not an effective defense, because with JavaScript, here's my JavaScript with no letters. I'm just using a couple special characters, and I'm using numbers only. Or how about this? Here's XSS with no letters or numbers, just a few special characters. Now, I obscured the name of the website. You can guess what the real name is. It's a swear word. I don't want to offend anyone. This is, so if you go to www.jsf.k.com, you'll see many, is that a picture? Wait, picture? Let's do it, come on, picture. If you go to this website, we can look at any single, got it, okay, good. If you go to the website, you'll see many examples of ways that you could obscure JavaScript to bypass filters or to represent JavaScript in many different ways. The point I'm trying to make is, if you're trying to filter JavaScript, I'll get through it. There's got to be a better way to defend against this attack category. Let's look at some attacks from the world's best. This is Gareth Hayes from Ireland. He's one of the world's top attackers in this category. This is a polyglot attack. Polyglot in English means somebody who speaks many languages, which is really nobody from the US, forgive us. But this.
England, for that matter.
What's that?
Or England, for that matter.
Well, they speak English and British, right? All right, stop. So, bad joke. So this attack, it's really a test, right? It's a JavaScript URL. It's a comment. I'm sorry, it will fit in a URL and execute. It will fit in a comment and execute. It will fit in a title, in a style, in a text area, even in a script block, in an XMP block, and still execute. It'll execute this SVG payload. When you mouse over it or unload it, it will execute the alert to prove the attack works. So if any of you are penetration testers or do security testing for a living, I would use this. This is fantastic. It's an attack that no matter where the browser renders it, it's going to execute, again, from one of the world's best. Here's two more of the world's best, right? This is Mario Heidrich from Berlin. This is Chris Christowitz from Poland. Chris Christowitz works for Google One project. Oh, sorry, Google Zero project. Mario works for Cure 52. These are some of the best that I know of, period. So I go, hey, Mario, show me the best attack you got. He's like this? You want something more fancy? No, this is great. This shows the login form from your actual website. That's the fetch login. And then it converts all the forms to evil.com. So he walks through the text of the web page and replaces any form action with evil.com. So it's your login page, it works, and when you hit submit, it submits to an evil website to steal some data. And here's Chris Christowitz. These guys are friends. He's like, hey, nice job, Mario, but I can do that same attack with like 50 less characters. The smaller the attack payload, the more places that we can utilize this attack. So he's still working on shrinking it to this day, right? How about this? Any of you like Bitcoin? Bitcoin? It's all fake, sorry. It's a big scam to steal from you, I'm sorry. But anyways, here I can use a coin hive to mine for Bitcoin through JavaScript, through cross-site scripting. Right? We see like AdSense. A lot of people are using AdSense to weaponize this attack. And so what you can do is you can build an advertisement that uses a link to JavaScript on your website that is safe and innocent. Get lots of people looking at your ad, then swap it out for CoinHive. This is, of course, very illegal. We would never do this unless you have written permission or a good lawyer. So let's move on. Last attack, here's a keystroke logger, right? We have the spy on key down. We're going to trap that event. So anytime someone puts a key down, we'll use a WebSocket to send that key to whatever to the website, to the attacker's website. So this is a way that I can literally do a keystroke logger through JavaScript to steal every keystroke from individual users. Do you think we should take this seriously, cross-site scripting? What's your name? Who said probably? What's your name? Stefan. I'm going to give you one more chance. Should we take cross-site scripting seriously, Stefan?
Yeah.
Good. No. No. One. What was the answer? Say it.
Yeah.
Stop. Good answer. Good answer. Let's talk about defense. That's why we're here. Does everybody have a good understanding of what cross-site scripting is now? It's injecting JavaScript into a website so other users of the website execute evil JavaScript. And I have complete control of that web page at that point. It's serious. Now, from a principle philosophy point of view, think about how you construct a user interface. I have data from JSON or data from the request or different variables that I add to some template. That's basically how it works. Which variables that we add to a user interface should we lock down? Which variables that we add to a user interface should we secure in some way? Should we look up the variable to see if it's dangerous before we protect it? No. Every single variable that you add to a user interface, we should assume it's dangerous and protect it in some way that we'll talk about in this presentation. We want to make sure every variable that we add, I also recommend don't protect it on the server or in the controller or the model of your code. Protect it in the user interface itself. So when you're building a strong user interface, it doesn't matter what data is fed into it. If you're doing it secure, your application should protect against this attack category. And please don't depend on other defenses. Things like validation, input validation, things like a web application firewall, other defenses, they're important, but they're not going to protect you all the time. I'm going to show you different techniques that will protect you all the time. So, and last, be careful of when developers provide automatic XSS defense. Anyone use React again? React? There's a function, and React is a JavaScript framework that's very popular. And they have React has a function, an assignment, dangerously set inner HTML. Do you think that's safe to use in React? No, it's living dangerously. It's going to allow cross-site scripting if you're not protecting it in some way. In Angular, we have the function bypass security trust as. This turns off Angular's automatic security protections. So whenever developers use one of these, it's usually a sign that they're disabling security that's built into a framework, and we should review it carefully for security. We're going to look at 3 different layers of defense, 4 actually. We'll look at escaping, HTML sanitization. We're going to look at DOM-based XSS and the safe use of JSON. We'll briefly mention content security policy as well. And so the first layer of defense is to do some kind of escaping. Let me explain what I mean by that. If this character is submitted by a user and sent to your user interface, what does the web browser think of this character? What kind of data is this to the browser? Is it display data or is it code?
Opening tag.
It's code. It opens a tag. How can I put this character in the browser in a safe way? It's what was that? What's the right escaping for this? Ampersand, LT for less than, and a semicolon, right? This is now going to display as a less than symbol without being treated like code in the browser. This is the heart of all cross-site scripting defense. We want to take every piece of data and convert it to a form that will not execute JavaScript. That's the main defense. If we look at Angular, you have the call ngbind, or your double curly brackets. This will automatically stop cross-site scripting. It will automatically do the escaping for you. Any HTML or any JavaScript, it will be escaped in the Angular framework, and it will not render. So this is an easy way for Angular developers to make sure they have good security. It's built in automatically. But what if you need to render HTML that was authored by a user? This happens often. Does anybody let users submit HTML to your server? It's common, right? We see this in social media. We see this in blog posts. We see this in comments. We sometimes let users submit different tags. So if you're going to allow HTML from a user, we can't escape because it will not render the HTML. Instead, we want to use an Angular ng-bind HTML. That will run an HTML sanitizer. It will render the HTML, but only safe HTML will render. All the extra JavaScript will be removed from the content. So how about React, right? When you add data to React, it's going to automatically do the escaping built into React. Most escape content will not execute JavaScript in React. But there's one way I can bypass React. It's a very famous JavaScript framework. If you're going to allow me to add a link to React, and I just add the link to React, it's going to escape it, but not well enough. Because if I submit a JavaScript URL, it will execute anytime someone clicks on it. We know there are URLs of type HTTP, of type HTTPS. There's also type JavaScript, which just executes when someone clicks on it in every browser except for Firefox. So this is a way to bypass React in certain browsers. A lot of people if you read about React, they'll say, we are perfectly immune to cross-site scripting, and they're just not right. There are some ways that we can bypass it. Now, the library that I recommend you use is called DOM Purify. DOM Purify is a JavaScript library. So when you're using, like React, dangerously set inner HTML, normally it will just execute that script. But I can say now dompurify.sanitize to any content that I add to React through dangerously set inner HTML, and suddenly that script will no longer execute. There's a very famous security library that's very well updated just for the purpose of cleaning up dangerous HTML that's authored by your users. So that takes us to here, right? That's how the escaping works, right? We do escaping, it's built into our frameworks. Anybody here use Go by any chance? So for Go, we have Go templates. They do the escaping for you automatically as well. If any of you are using older technologies, like Java server pages or PHP templates, you may have to do the escaping yourself. And every single language in the web has its own escaping library built into it. It's in the framework or as a third-party library in some way. Let's go back to HTML sanitization and explain what I mean by this. So phase one is we have to escape all of our strings, and we have to avoid JavaScript URLs, because they'll execute even if you escape them. So now what about HTML? I use this widget often. This is a TinyMCE. It's a WYSIWYG editor. What you see is what you get. So when I hit submit on this content, it's rich text. TinyMCE will submit a chunk of HTML to the server. Why will escaping not help us when the user submits HTML to our application? What do you think? Will escaping help us here? Again, the user is submitting HTML. What will we see on screen if I escape this? Yeah, the actual code. Will it be safe? Yeah. Will it be functional? No. It'll break the application. Because the goal is if a user submits HTML, we want to render that HTML, right? And so what I recommend you do instead of sanitizing again, we want to use an HTML sanitizer. And I'll mention two of them, right? And by the way, I'll post this live. I'll take this presentation and deliver it to Sebastian so you can all get a copy of it. So here's the sanitizer. I recommend DOM Purify for JavaScript, and I recommend the Owasp Java HTML sanitizer project for server-side validation. Here I am in Java. I'm running it through a policy. I'm allowing the title tag. I'm allowing an href attribute and an anchor tag, and so on. I'm specifying which tags are legal. Then down here, as you send me HTML, I'll sanitize it, and anything that's not one of these tags will be removed from the markup, and everything remaining will be safe to render to other users. Now, this is happening on the server. I want to do my defense not up on the server. I want to do my defense in the user interface itself. This is why I like DOM Purify so much, because it's a very it's something I can do in JavaScript inside of React or inside of the Vue.js framework. So as I submit HTML to your server, and then you later on bring it back to the client, I can do the HTML sanitization, not on the server, but in React itself. Now the defense is closer to where the attack launches. It's a better location to apply this defense. Let's look at DOM XSS next, right? And so with DOM XSS, and this is what we didn't talk about in class today. Let's look at this, right? So if we're now doing JavaScript programming, building our own user interface, right? All of these functions are extremely dangerous. The eval function, document.write, document.writeLine. Why is inner HTML so dangerous, by the way? If I'm building a user interface and I use the assignment inner HTML, why is that dangerous? Anybody?
Because it still allows tags, right? I don't really write it.
Yeah. Yeah. What does inner HTML do?
Puts code inside the HTML tag.
Exactly, including JavaScript. It will just execute. And a lot of people use inner HTML in JavaScript work, and it's insanely dangerous. So this is what's safe now. There's very little in JavaScript that's safe, and this should be all you need to build a secure user interface, right? We can say element.textContent, that will never execute JavaScript, no matter what you feed into it. We can say element.className, that's always safe as well. This is in JavaScript, doing JavaScript data flow. We can say element set attribute, as long as it's a safe name, not an event handler, that's going to be safe as well. We can say form field.value, that's always going to be safe. It's not going to execute script. Or we can say document text node, that's going to be safe. Or create element. Or how about this? Inner HTML, we can make it safe if we use DOM Purify to sanitize the content. And by the way, the W3C, the World Wide Web Security Group, is considering adding DOM Purify directly into the browser as native functionality in the future because it's so important for security. Everybody with me so far? Sure. Also, if we're going to parse JSON, use JSON parse. Now, let's talk about using safe functions safely. I've told this to developers, please use text content to render content. And someone did this in a Java server page. This is a server-side rendering template, and this code is completely unsafe. And they asked me, but Jim, you told me to use text content, and I did, but they still hacked my website. What's wrong? Why is this so unsafe? Is this data being rendered in the browser? Where is it being rendered? On the server. So here's request.getParameter. Even though it's single quoted in text content, we haven't even got to the browser yet. This is being assembled on the server. So what would your attack look like to bypass this? I would say single quote, semicolon, attack, 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 and then a comment to comment out the last single quote. So the point I'm trying to make is these safe JavaScript functions, they're not safe on the server. They're only safe when you're doing JavaScript data flow in the browser itself. And here now I have a function in JavaScript that's going to run in the browser that will be safe. I want to do some cool stuff. I have an element and some data. If I say element text content is data, no matter what attack I get to the data variable, that's going to be safe. Cool? So what else do we have here? Safe client-side JSON handling. So I'm moving fast. This is going to be a shorter presentation. We have beer drinking and talking to do, right? It's going to be like a half hour. We're nearing the end here. Let's talk about how to do JSON in a safe fashion. Here I am doing JSON.parse. I'm just trying to parse some JSON. A lot of the documentation about JSON, they said to use the eval function to parse JSON, and in older browsers, it would execute data in JSON. So just make sure you're doing JSON.parse. This is pretty basic in 2018. But how about this? A lot of the documentation around React and other libraries, they recommend that you embed JSON into a web page directly. And if you're going to do that, you want to use the Yahoo serializer to serialize JSON before you add it to a browser. A lot of the documentation I read says to use the stringify function in the browser. And this is completely unsafe in terms of embedding JSON. So I recommend that you go and look anywhere you're stringifying JSON in the user interface, instead serialize it. When you serialize JSON in a user interface, it's going to escape all the right characters and let you embed it in a safe fashion. This is a common performance pattern, right? I often, instead of having to prefetch my JSON, make an AJAX request, for my initial page, I can embed the JSON, send it to the browser, and it helps me save a round trip of fetching the first piece of JSON, and yet still take less work on the server because they're not assembling the entire user interface. The last couple of things we can do is sandboxing. Has anybody ever told you to put an advertisement on your otherwise secure web page? It's very sad, isn't it? Any secure website does not do advertising. When you add advertising to a web page, what you're saying is, I hate security, I love advertisements, and I don't care that that advertisement's going to inject bullshit content into my web page. Pardon my language. So we have, whenever I'm forced to add third-party content to my web page, there's a couple things. I'm going to use this iframe sandboxing here. What I can do is I can load the advertisement or other potentially malicious content from a third party or partner and say sandbox is quote, quote. When you sandbox other content, it stops JavaScript from running, it stops form from submitting, it stops navigation out of the frame, it does not allow JavaScript to talk to the rest of the web page outside of the frame, it stops full page media from running, it stops applets and Flash from running, it stops automatic media playing. Advertisements are the death of security. Don't do it. If you care about, like, your bank should not be running advertisements. I'm sorry. And so and if you're forced to, very often I'm just an engineer and I'm a security engineer. We cannot use ads. And my boss says, Jim, you're going to put ads on the web page. And I'm like, I don't think we should. And what does the boss say? Go put the ads there. So what I do is, I'm being a little sneaky. I put them in a sandbox. Usually an advertisement agency will pay me like 3 to 4 cents a click for a popular website. But if I put the ad in an iframe, they'll pay me like a quarter of a penny per click because they can't get data about the rest of the web page. So usually I can sandbox it and my boss won't figure it out for a couple months. So at least I get a couple months of security. I went really fast. We're almost done here. I hope it's still of value. Even though it's a brief talk, we have more time to do what? Drink beer? Yeah. Good. And I'll also answer questions at the end. Last but not least, we have content security policy, right? This is a W3C standard to help protect us from cross-site scripting. This is first published CSP3 in September of 2016, and it's very powerful. It's a response header that your server delivers to the browser, and if the browser supports content security policy, I can limit how JavaScript is going to execute. So in this policy here, I'm saying default source is self, and what that does, and I say script source is self. When I say script source is self, I am disabling all execution of JavaScript on the web page itself. It will only allow me to run JavaScript that comes from a separate JS file or from a JS file from this different domain here. But if anybody adds JavaScript to the page itself, it's going to stop working. Should we be adding JavaScript in the middle of a web page anyways? No. We've been told not to do that for about a decade now. All of our JavaScript, in theory, should be in a separate JS file that uses event binding to bind into our page. And if we add a policy like that, all of our JavaScript that's doing event binding will work, but any JavaScript that gets injected will not work. This almost completely eliminates cross-site scripting. And the browsers now support this very well. There was a presentation back in 2016, which is either a really great name or a really terrible name based on your perspective of the world. It's called Making Content Security Policy Great Again. A little bit too soon, I'm sorry. This is a presentation by Michel Spagnuolo and Lucas Weichelbaum. Anybody who wants to learn more about content security policy, I recommend that you look into this in great detail. It's a great presentation. Now the power is, it lets me do a strict dynamic policy here. Where's my, there we go. It lets me do a strict dynamic policy. Now what that means is, when I have this policy, it's for content security policy 3-level browsers. So step 1, I say script source nonce random. Now what that means is, any script block that I'm forced to add to a web page, I can now add a nonce to it called random, and that script will be allowed to run. This is what remember, if you don't have any JavaScript on your web page, you can just do this and you're done. But how many of us add JavaScript into a web page itself? A lot of us do that. I don't think it's a good idea, but that's the reality. So if you do have JavaScript in your web page, I can add a nonce to each script and it will be allowed to run. Any other script that doesn't have the nonce will not be allowed to run. I can then say strict dynamic, and what strict dynamic says is, if you include a JavaScript file with the nonce, I will automatically load all the dependencies for you. Normally, we have to add a whitelist here of every single JavaScript file that we want to run, and that's not easy to maintain in a complicated website. So if that's hard to maintain, just say strict dynamic, and you just include the main JavaScript files in your main server, and all the dependencies will load for you automatically. And because I have nonce random turned on, the unsafe inline will be turned off. And because I'm using strict dynamic, this policy to allow HTTPS links to JavaScript will also be disabled. Now, with the same policy, as we drop down to content security policy level 2, strict dynamic is not supported. So if I still use the nonce to allow script blocks to run with that nonce value, the unsafe inline is still turned off. But then we have HTTPS. What this says is, any JavaScript file that starts with HTTPS, I'm going to let it run. This is not very secure at this point, but the goal is compatibility. Most of our browsers are new browsers now because they automatically update. So this is the main policy we care about. But if we have to run this in a very old browser, like CSP level 1, then there's no nonce support. There's no strict dynamic support. And we're saying let any JavaScript run in line in the middle of the page, and let any JavaScript that's HTTPS based to run as well. This is not very secure, but it's about compatibility, so I can build one policy that works in any browser. And because most of us are going to have a new browser, right? And by the way, object source is none. That says no plugins are allowed to run on my web page. Flash, Java on the client, all that gets automatically disabled when you say object source is none. Especially anybody doing Flash development, please say no. Flash is freaking evil from a security point of view. Nobody should use Flash anymore for anything. In fact, your computer should have Flash fully removed from it. It's such a dangerous security violation today. Flash is garbage. I hate to say it, but it's true. Let's look at the conclusion here. So we went through all of this in this presentation, right? We talked about if you have a string, escape it. If you have a URL, it must only be a JavaScript URL. If you're allowing users to author HTML, we have to do HTML sanitization. We have to use JavaScript safely. We should sandbox any potentially dangerous content from third parties. Parse JSON correctly. Serialize JSON if you're going to embed it, and use content security policy in case any mistakes are made so you can still protect the website if other defenses don't exist in your code. I hope those answers were satisfying. I hope the presentation helps you. Any questions? I take your questions very seriously. Write me anytime. I'll be sure to post these slides to Sebastian so you can all have a copy of it. Go forth and write secure code. Thank you so much for your time today.